Okay, so sharing my screen and just kind of just going over what's in Schoology and what we're doing on today. So today we are continuing our conversation into momentum, and we're going to talk more about impulse on today. So um, the goal is, of course, is to complete this assignment together, where this says momentum and impulse practice part 2. We're going to work on these problems together. There are about 15 problems on here, and as soon as we get done with that, you guys should be ready to do the momentum and impulse math assignment. Okay, so that is the goal for today. Um, I just put the link in to the attendance form in the chat box. Now, okay, so on Tuesday, now as you guys know, I was not live on the Zoom call on Tuesday because I had to administer a PSAT test. But I did post a YouTube video, and hopefully you guys were able to watch that video because in the YouTube video, I introduced the concept of momentum. And remember what I said, that momentum is defined as the quantity of motion of a moving body. It is measured as the product of an object's mass and velocity. So remember, this was the equation that you guys used last time for your assignment. Momentum is equal to mass times velocity. Of course, this right here, keep in mind what your units for momentum are. Your units for momentum are kilograms, meters per second, which makes sense, right? Because you're combining mass and velocity. So kilograms times meters per second gives you that for your units. So momentum is mass times velocity, and we typically use a little p to represent momentum in physics. Okay, and so momentum is defined as the quantity of motion. And remember last time how I defined this. Um, well, remember last time how I explained this. So let me bring up this picture here. So remember what I said. Of course, for those of you guys who were able to watch the YouTube video, remember how I said anything that is in motion has momentum. So, for example, imagine a linebacker that is running and he is about to tackle the quarterback. As long as that linebacker is in motion, he has momentum. Now, momentum can be, well, an object can have a very large value for its momentum, or it could have a very small value for its momentum. All right, so if the running back is running really, really fast, then he has a lot of momentum. Okay? If the running back is running, at an average speed, then he doesn't have as much momentum. If he's running at a small speed, he has a low momentum. So guys, got that? So momentum just basically means the magnitude of motion. That's how you can think of it, the magnitude of motion. Now, um, one of the things I said last time, it is very useful for physicists to think of momentum in these terms because it turns out there are some very real world applications to this. For instance, whenever insurance companies are analyzing collisions, using the equations for momentum are very helpful in those situations. Um, and why is that? Let me stop sharing my screen here for a moment. So um, it turns out that anytime that um, two or more objects are involved in a collision in nature, the total momentum in that collision stays conserved. What that means is the total momentum stays the same. It stays constant. Let me give you guys an example of what I mean by that. So, um, um, many of you guys have seen this before. This is what is known as a Newton's cradle. Okay, and so the Newton's cradle perfectly demonstrates how momentum is conserved in a collision. And y'all seen this before, right? Because if I take one ball on this end and I release it, as I release it with a certain momentum, right? There's a certain magnitude to its motion as it moves from here to here. And of course, as this ball collides with that ball, it passes its momentum along to that ball, which then passes its momentum to that ball, and that transfers the momentum to that ball, and ultimately that ball, right? So the total momentum stays conserved because notice if one ball goes in on one end, then one ball comes out the other end. What if I take two balls? So what if I increase the mass of the system? I've increased the system's momentum. So if two balls go in, notice two balls come out the other end. Okay. What if three balls go in on this end? Well, let's see. So if three balls go in, okay, and notice three balls come out. So you guys clearly see that the overall momentum stays conserved or stays constant in the collision. So if four balls go in, four balls come out the other side. So you guys clearly see that this perfectly demonstrates why momentum is a very important concept whenever it comes to analyzing collisions. In this case, we're analyzing collisions between two balls. So so just to give you guys a little FY, a little just a little FYI, a little side information, that momentum is very important for insurance companies and things like that whenever they're analyzing real world collisions in nature. They actually do use these equations that we're going to be working on today. Okay, so let me go ahead and share my screen again. So that was the equation for momentum. On today, I am going to introduce you guys another equation, and that is the equation for impulse. So the equation I'm going to introduce you guys today is the equation for impulse. And impulse in physics is mathematically defined as force times delta t, where delta t is understood to be a time interval or a change in time. Right? So this is another equation that we're going to use in this unit, and that is the equation for impulse. So F stands for force, delta t stands for change in time, and just so we're clear, everybody should know that the units for force are newtons, and the units for time are seconds. So therefore, guys, overall, when you find the overall unit for impulse, it's just Newton seconds NS. So Newton seconds are the units for impulse, which hopefully should make sense to you because again, you're combining force and time. So force multiplied by delta t gives you Newton seconds, which are the units for impulse. And guys, impulse is nothing more. So like, well, let me back up a little bit. Imagine that you have an object and you apply a force over a period of time on that object. That's what is known as impulse. Anytime you're pushing on an object and you push over a period of time, we say that you're applying an impulse on the object, right? And so the basic idea, guys, is that the longer you apply that force, then the greater the impulse. Okay. And in just a moment, we're going to see how impulse relates to momentum because there's a direct relationship between the two. And we're going to see what that relationship is as soon as I get done working a few example problems with you guys. Okay. So
can you keep it up for a couple more seconds?
Yeah, there you go. Yeah, so these are the two equations we're going to be using today. We're going to be using impulse, which is force multiplied by time, and we're going to be using momentum, which is mass times velocity. We're going to use both these equations all today. And in just a moment, I'm going to show you guys how these equations relate to each other. Okay. Serenity, you good?
Almost.
Okay.
Done.
All right. Okay, so now what I'm going to do some practice problems with you guys because if you if you understand how to do all these problems that we're about to do right now, you should be good on the homework assignment. So this right here where it says momentum and impulse practice part 2, these are just problems for us to practice as a class. We're going to do this together, and then this is what you guys have to turn in later on, the homework assignment. It says momentum and impulse math assignment. So as we work on these 15 problems, you guys should have enough knowledge to be able to do this assignment whenever I post it. Okay. You know what? Let me open this file up in Kami. That way it's easier to write on. Okay, so there's a total of 15 questions. I'm going to do about half of them with you guys first, and then as soon as I get done with half of them, I'm going to talk about the relationship between momentum and impulse, and then we're going to come back to this because the easier problems are introduced first, and then as we get towards the end of it, we get into the more difficult problems. Well, they're not difficult; they're just not as easy. It's the first few problems. Okay. So let's look at number 1. Okay. Number 1 says, what is the momentum of a 0.2 kilogram steel ball that is rolling at 3 meters per second? So it's a velocity of 3 meters per second. So here we just use our momentum equation. Momentum is equal to mass times velocity. So momentum is equal to mass times velocity. Okay. So if our mass is 0.2 kilograms and our velocity is 3, all we do is just multiply mass times velocity, this times this, to get the overall momentum. So 0.2 times 3 turns out is 0.6 kilograms meters per second. So that is the answer to number 1. Remember to be sure that you include your correct units for momentum, which is kilograms meters per second. I just put the attendance form in the chat box again. For those of you guys who need it. Okay, so number 1 is pretty easy. Moving right along to number 2. Number 2 says if a ball is rolling at a velocity of 1.5 meters per second and has a momentum of 10 kilograms meters per second, calculate the mass of the ball. Okay, so momentum is equal to mass times velocity. Okay, so in this case, they actually give us the momentum. They tell us the momentum is 10. They even give us the velocity. They say the velocity is 1.5. So the question is, how will we solve for mass? How will we do that? You guys should know how to solve for mass. So you guys should know how to solve this equation for mass. It's really easy to solve this equation for mass. Okay, so in order to get mass by itself, it should be obvious to you guys that I have to do the opposite of multiplication. I have to divide both sides of the equation by 1.5, right? So if I divide this side of the equation by 1.5, that goes away, and whatever to do one side of the equation, I have to do to the other. So now divide that by 1.5. Okay. So 10 divided by 1.5 gives me my mass, right? So 10 divided by 1.5 gives me my mass. Well, what is 10 divided by 1.5? Again, hopefully everybody has a calculator. Plus, you're going to need one for this assignment. That would be 6.67 kilograms. So that's the magnitude of the mass for number 2. Okay. Really easy. Again, let's just keep going. Like I said, I want to get the easy problems done first. Number 3 says determine the velocity of an object that has a mass of 2.5 kilograms and a momentum of 1,000 kilograms meters per second. Okay. So once again, we know momentum is equal to mass times velocity. They tell us momentum is 1,000. They tell us the mass is 2.5. And they ask us to solve this equation for velocity. That's really easy. You guys know how to solve this equation for velocity, right? Because if you have 1,000 is equal to 2.5 times v, you just divide both sides by 2.5. That goes away. Whatever you do to one side of the equation, you have to do to the other. Okay. When we solve for v, on number 3, we're left with 400. Like if you put that in your calculator, 1,000 divided by 2.5, you get 400 meters per second for the magnitude of your velocity. Again, guys, these are the easy problems. Just like I said, I'm starting out with the easier problems first before we get to the ones that are slightly harder. Super easy. So hopefully everyone got that. Hopefully everyone understands that. And again, this video will be on YouTube. Number 4 says, what is the momentum of a 100 kilogram fullback that has a velocity of 3.5 meters per second? Okay, so, well, momentum is super easy. Momentum is just mass times velocity. If the mass is 100 kilograms and the velocity is 3.5, when you multiply those two, what you get 350 kilograms times meters per second. Okay, which is number 4. Okay. Any questions so far? All right, number 5 says calculate the impulse of a 5 Newton force acting for 4 seconds. Okay, so now this is where we get into the equation I just introduced to you guys at the beginning of this class. That is the equation for impulse. So impulse is just your force multiplied by your time, some sort of time interval, or some sort of change in time. Okay, so here, impulse is equal to force. You know what? Force times change in time, or force times delta t. That's just another way of saying that how long the force is acting. Okay, so if I have a 5 Newton force acting for a total of 4 seconds, right? That's the time interval. So what is 5 times 4? It's easy. Yep, 20. Now, since we're solving for impulse, guys, we're going to put our units Newton seconds, right? Impulse is in Newton seconds, right? Because that's really conceptually what impulse is. It's just a force acting over some period of time on an object. So, and guys, that's pretty obvious. If you're pushing a box, it should be obvious to you that the longer you push that box, the faster and faster it's going to move, right? So, and the reason why, because the longer you apply that force, the greater the impulse you're imparting on that box. That's the basic idea behind impulse. It's just force acting over a period of time. Okay. Okay, look at number 6. Number 6 says if the impulse is 35 Newton seconds and it lasts for 3 seconds, what is the magnitude of the force? Okay, so guys, look at this equation up here. So if impulse is 35 Newton seconds, so they give us the impulse. Okay. They tell us that the force lasts for 3 seconds. So I'm going to plug in 3, for my time interval, because that's what we're told. Now, how do we solve for the magnitude of this force? Super easy. You guys know how to do that. Divide both sides by divide both sides of the equal sign by 3. So 35 divided by 3, if you put it in your calculator, you're gonna get a force value of 11.67 newtons. Okay. All right. Let's keep going. Okay. So look at number 7. Number 7 says if the force of an impulse is 30 kilograms meters per second, is 6 newtons, how long does the impulse last? Okay. So here, so let's write our equation for impulse. Force times time. Okay. So here they tell us that the impulse is 30. I'm sorry. Okay. Um, so the impulse is 30. The force is 6. So it says how long does the impulse last? How long? In other words, they're asking us to solve for the time interval. So y'all know how to solve this equation for delta t. That's pretty easy. If you have 30 is equal to 6 times delta t. You know, basically you would just divide by 6. That goes away. Whatever you do to one side, you have to do to the other. You guys know what 30 divided by 6 is. 30 divided by 6 is equal to 5. So 5 seconds is our delta t. Um, is our time interval for this problem. And by the way, on number 7, if you notice for impulse, instead of using Newton seconds, they use kilograms meters per second for the units. In just a moment, I'm going to explain why they do that. Because technically you can do that, and I'm going to explain why that is. But typically when you see impulse, the units are Newton seconds. But in a moment, I'm going to explain why you can do that. Or why you can also see it occasionally in other units. Look at number 8. Number 8 says calculate the impulse of 10 newtons of force acting for 2 seconds. Super easy. Remember, impulse is equal to force multiplied by time. If the force is 10 newtons and it acts for 2 seconds, 10 times 2, it's obvious what that is. That is 20 Newton seconds. That is number 8. Okay. All right. Now, before I move on to number 9 and 10, I want to go back to this concept that I described at the beginning of class. That there's a direct relationship between impulse and momentum. Even though these are separate equations, one equation says that momentum is equal to mass times velocity. The other equation says impulse is equal to force multiplied by time. So even though these use different variables, believe it or not, there's a direct relationship between these two equations. These two equations, in fact, equate to one another, like their numerical values equate to one another. What is it that I mean by that? Well, let me just show that to you guys, how these two equations are related to each other. So, in physics, we have what is known as the impulse momentum theorem. And so here's where we see a direct relationship between impulse and momentum. And I'm going to prove to you guys what that relationship is. In fact, I'm going to prove it to you guys mathematically. Um, the way I'm going to prove it to you guys, I'm going to start off by writing Newton's second law. This is a very common equation that you all should know because we've been using it all year. Newton's second law says that force acting on force is equal to mass times acceleration of an object. So that's Newton's second law. Now, in order to prove that impulse and momentum are related to each other, I'm going to kind of mathematically manipulate this equation a bit. Well, not really math. Yeah. Yeah. I'm going to change forms just a little bit by using some algebraic manipulation. So let's start with acceleration. Everybody in here knows that acceleration, by definition, is change in velocity divided by change in time, right? Acceleration just means how an object changes its velocity. So let me write that down. So acceleration is change in velocity divided by change in time, right? Because if you're accelerating, you're increasing your velocity. If you're decelerating, you're decreasing your velocity. That's what acceleration means, a change in velocity. Sorry, I just kind of just wrote acceleration in another mathematical form. Okay, but this is still Newton's second law here. Now, there's one more thing I'm going to do to this equation here. You guys see this delta t? I'm going to manipulate this equation by multiplying both sides of the equation by delta t because it's going to get rid of that in the denominator. So if I multiply the right-hand side of the equation by delta t, that goes away. Remember, whatever you do to one side of the equation, you have to do to the other. That means I have to multiply the left-hand side of the equation by delta t. Okay. And when I do, notice what I get. I want you guys to notice something here. Look at the left-hand side of this equation. Force times delta t. What does that remind you of? You notice that's the equation for impulse. Impulse is equal to force times delta t. So that is the equation for impulse. Now look at the right-hand side of this equation. Notice on the right-hand side of the equation, you see a mass and a velocity. What do we get when we combine mass and velocity, when we multiply mass and velocity? What does that sound like to you? Well, go back to your equation for momentum. Momentum is mass times velocity. Okay. Now, just to be specific here we'll multiply mass times change in velocity. In other words, this side of the equation means change in momentum, right? Because that's what delta means. Delta means change. So this side of the equation is change in momentum. So guys, here's what I'm trying to tell you guys. Those two equations that I just gave you guys, the equation for impulse and the equation for change in momentum, what I'm trying to tell you guys is that these two equations, they can be equated to one another. Their numerical values equal each other. That's what I'm trying to tell you. So in other words, if you know the value of the impulse acting on an object, then you know the change in momentum of that object. In fact, an impulse causes an object to change its momentum. Okay. Let me give you guys an example of this. So right now, this book is sitting in my hand. Okay. As the book is sitting in my hand, it's at rest. It has no momentum. It has zero momentum. But if I want the object to change its momentum, that's easy. I just apply an impulse on the object because, right, what is an impulse? An impulse is a force acting over a period of time. So if I apply an impulse on this object, okay, the book clearly changes its momentum, right? So initially it had zero momentum, and then it had a lot of momentum because you saw me shove it across, the room. So that's what that equation means. That equation means that an impulse will cause an object to change its momentum. Okay. So an impulse acting on an object, a force acting over a period of time, causes an object to change its momentum. This is what is known as the impulse momentum theorem. Okay. Now that we know that, let's go back to this worksheet here, and now let us complete these last few problems. Let's finish this up. Okay. Number 9 says an 8-kilogram object starts at rest. It is then pushed by a 15 Newton force for 8 seconds. Calculate the impulse acting on an object. Now, guys, sometimes on some of these problems, they'll give you extra information that you don't really need. For example, they tell you that the mass of the object is 8 kilograms, and it tells you that it starts for rest. And they ask you to calculate impulse. But guys, you really don't even need to know this, because remember what the equation says. As long as you know force and time, you can easily calculate impulse. And we do know force and time. We know the force is 15, and we know the time is 8 seconds. So as long as you know that, all you do to calculate impulse is to multiply those two values. So impulse is equal to force times time. So 15 newtons of force multiplied by 8 seconds. When I do that, I get 120 Newton seconds for the magnitude of my impulse. Okay. Now, look at number 10. Number 10 says, calculate the change in momentum for number 9. Well, think about this for a second, guys. We technically don't have to do any calculations with any numbers, because we know what the change in momentum is. How do we know what the change in momentum is? Well, look at the momentum impulse theorem. This theorem says if we know the value of the impulse, we know the value of the change in momentum, because those two numbers equal each other, right? This equals this. So if the impulse was 120 Newton seconds, then that means the change in momentum better also be 120. So 120 kilograms meters per second represents our change in momentum for number 10, right? These two numbers should equal each other, right? So change in momentum is equivalent to the impulse, because that's what this theorem right here says. The magnitude of this value is equivalent to the magnitude of that value. Got it? Let's look at number 11. Number 11 says a 12 Newton force pushes on an object for 4 seconds. How much momentum did it gain? Okay. Now notice, guys, what they're asking here, they're asking us to calculate change in momentum. But notice what they give us. They give us force and time. So in other words, they give us everything we need to solve for impulse. Well, remember, if we know the impulse, we know the object's change in momentum. Okay, so in other words, if we know the impulse acting on the object, we know how much momentum that object gained. In other words, how much the change in momentum for that object. Okay. So remember, impulse is equal to change in momentum. Okay. So if we know the impulse is 12 times 4, right? Because that's what impulse is. Impulse is force times time. What's 12 times 4? 12 times 4 is obviously 48. So if the impulse is 48 Newton seconds, then that means the change in momentum better be 48 kilograms meters per second. So that's number 11. If you know the impulse, you know the object's change in momentum. So that's how much That's how much momentum was gained by that object after that force acted on it for 4 seconds. All right, let's finish this up here. 4 more. Look at number 12. Number 12 says a 10-kilogram object is initially moving at 6 meters to the right, and 11.5 Newton force then pushes to the left on the object for 2 seconds. Calculate the impulse acting on the object. Okay. We know what impulse is. Impulse is force multiplied by delta t. Okay, what is the force? The force is 11.5 newtons, and that force acts for 2 seconds. But one more thing I want you guys to notice here. Look at what it says. That force is acting toward the left. So if the force is acting to the left, this 11.5 better be negative. All right. So negative 11.5 times 2 gives me negative 23 Newton seconds. Yes, guys, you can have a negative impulse. There's a such thing as having a negative impulse. Just like there's a such thing as having a negative change in momentum. You can have negative numbers. Okay. All right, number 13. Almost done here. Number 13 says an object has a mass of 2 kilograms. It was initially moving at 25 meters per second before a force acted on it and slowed it down to a speed of 10 meters per second. What is the magnitude of the impulse acting on the object? Oh, okay. Well, so notice they asked for the magnitude of impulse here, but notice all the information that they give us is information to calculate the change in momentum. Right? They don't give us force or time, but they do give us masses and velocities. So they give us everything we need to solve for the change in momentum. But guys, if we can solve for the change in momentum, then you better believe we can solve for the impulse. Well, what is change in momentum? Momentum is mass times change in velocity. So let me make this bigger here so I can write this down. Okay. So just so we're clear, guys, everyone in here knows change in momentum just means mass times change in velocity. But guys, what does delta V means right here? Remember what delta V means? Change in velocity just means final velocity minus initial velocity. That's what change in velocity means, right? So, all right, let me keep going here. So, if the mass is 2 kilograms, so we're going to plug in 2 kilograms for our mass. We know what the object's final velocity is. You know, it said it slowed down to a speed of 10 meters per second. So that was its final speed or its final velocity. We know that it was initially moving at 25 meters per second. So we're left with 2 times negative 15. And what is 2 times negative 15? Well, that's easy. Yep. Thank you. Negative 30 kilograms meters per second. So guys, that right there, that is the change in momentum of this object, negative 30 kilograms meters per second. So that's the change in momentum, negative 30. But remember, guys, the question asks for the impulse. Remember, if we know the change in momentum, we know the impulse. So that means the impulse better be negative 30 Newton seconds. Because if you know one, you know the other. So that is our answer for number 13, negative 30 Newton seconds. Okay. Number 14 and 15. Okay. Number 14 says a 30-kilogram object is at rest. A 50 Newton force pulls to the right on the object for 7 seconds. Find the impulse. Super easy. We know how to find impulse. Impulse is just equal to force multiplied by time. So the force is 50 newtons. The time interval is 7 seconds. So 50 times 7 is equivalent to 350 Newton seconds. So that is our impulse. Okay. Last one, look at number 15. Number 15 says an object experiences a 30 Newton force acting on it over a period of 5 seconds. Well, what's the overall change in momentum of this object over this period of time? So, guys, remember what this theorem says. If we know the impulse, we know the change in momentum, right? Because that's what it says. It says impulse acting on an object is equal to the object's change in momentum. Okay? So, if the impulse is force times time, right? So, it's force, which is 30 newtons, times time, which is 5 seconds. Okay. So 30 times 5, that is 150 Newton seconds. Okay. But it says, what is the overall change in momentum over this period of time? Well, it's easy. If the impulse is 150 Newton seconds, that means that must be the value for the change in momentum. The change in momentum better be 150 kilograms meters per second. So that is our change. That is the magnitude of our change in momentum. It is 150. Okay. Any questions there? Now, guys, I'm gonna say this on the assignment. Look very closely at your units. So if the problem asks you to find the magnitude of the impulse, then you would put your answer. I mean, you will look for your answer in Newton seconds. Okay. If it asks you to find change in momentum, you will look for your answer in kilograms times meters per second whenever you're doing those multiple choice problems. Okay. Now I know, like at the top right here on number 7, even though they on number 7 they said the impulse was 30, and then they gave you the units for change in momentum. Technically, technically you can do that. You can use the units for momentum. You should be using the units for impulse. You can do that because the two are numerically equal to each other anyway. So in some problems you will see them kind of you know flip flop the units or kind of use the units interchangeably. Technically, you can do that, but for this particular assignment I'm going to post, just get in the habit of using these units for impulse and these units for change in momentum. Even though the numerical results are the same, just know for on this assignment, whenever I ask for impulse, look for your units in Newton seconds, and whenever I ask for change in momentum, use your units for kilograms meters per second. Okay. Also, there's one more thing that I want to say before I let you guys go. On this homework assignment, some of the questions may ask you to solve for the net momentum. Okay. So let's say like they give you several masses, like mass A, mass B, and mass C, and so on, and they give you values to find the momentum of each individual mass, and they say, okay, so what is the net momentum of all the masses? Guys, remember what net momentum means. Net momentum just means the sum of the individual momentums. So in other words, anytime it asks for net momentum, that just means you just add up all the individual momentums to get the total momentum, right? So net momentum is just another word for total momentum. Okay. Just please keep it in mind whenever you guys are working on the assignment. Net momentum is just another word for total momentum. Okay. Any questions? Any questions for me?